Introduction. Going for a long ride, check for water in your vehicle. Wait, what, don't they run on diesel or petrol? Yeah right, why we need water then? Water is circulated in engine to keep it in optimum operating temperature range. Yes, we have got an optimum temperature range. We cannot cool it down too much, neither we can afford it go above a safe temperature limit. Ever imagine what would happen if your engine cooling system is not working properly? You will end up welding the piston rings to your engine cylinder walls, due to expansion of piston rings due to excessive heat. So now it's very clear that we need to understand how it works. Main components of engine cooling system. 1. Water pump. It is said to be the heart of engine cooling system. Water pump has a radial impeller inside its casing which is driven by engine itself. Serpentine belt is used to deliver rotational motion of engine main pulley to the water pump pulley. 2. Radiator. Radiator acts as a heat exchanger for an engine. It is usually made up of aluminium, and of lots of small diameter pipes with fins mounted on them. It exchanges the heat of hot water coming from engine with surrounding air. It also has an inlet port, outlet port, drain plug, and a pressure cap. 3. Thermostat. It is the thermostat which acts as a valve for coolant and allows it to flow through radiator only after exceeding a particular temperature value. Thermostat has paraffin wax in it which expands at a particular temperature and opens it up at that temperature. 4. Coolant temperature sensor. As name suggests, it is a temperature sensing device in engine cooling system and it monitors the engine temperature. It provides the data required to control the operation of radiator fan. The engine temperature display at driver's console gives reading according to the data provided by coolant temperature sensor. Further, in the ECU-controlled vehicles, its data is used to optimize the fuel injection and ignition timings of engine for better performance of vehicle. 5. Rubber hoses. In engine cooling system, these rubber hoses are required to make connection between water pump, radiator and engine so that water or coolant will flow through them, thus completing the circuit. 6. Radiator overflow tank. It is a plastic tank generally mounted close to radiator and has inlet port connected with radiator and one overflow outlet. It is the same tank where you put in water before ride. Working. As piston moves up and down in engine cylinder due to the pressure created by the gases formed as a result of burning air-fuel mixture. We have water vents along the length of engine cylinder and engine block, and these vents circulates through engine head and remove the heat, with flowing water from the engine in best possible way. So let's start with water pump, and let's say engine just start and it's cold. Water pump inlet and outlet is connected to the engine with help of rubber hoses. We have thermostat mounted in path of outlet to the engine, so water is pumped by this radial pump through thermostat into the engine water vents. Thermostat does not allow the water to go into radiator circuit until engine is at low temperature, and water comes back to pump through outlet hose. Coolant temperature sensor is mounted just near the thermostat. As water keeps on circulating, it extracts heat from the engine and its temperature rises. As it reaches a temperature between 160 to 190 Fahrenheit, it melts the paraffin wax in thermostat and opens it up. So now this hot water is circulated through radiator circuit. Water enters the radiator through inlet port and exchanges its heat with air as it flows through number of small radiator pipes, and with help of fins attached to these pipes. But as engine operates at higher RPM, engine's temperature goes up, so does the coolant's temperature. This coolant gets heated up to such a high temperature that it would create a high pressure situation in radiator. If such a high pressure keeps on increasing, it would bust out the radiator pipes, which we don't want in any case. So to deal with this pressure, we have pressure cap and a radiator overflow tank. When pressure in radiator reaches up to 15 psi of pressure, it lifts up the spring in the pressure cap, thus opening a port for coolant to be transferred to the radiator overflow tank, thus keeping pressure in control. When coolant flowing into the overflow tank exceeds its volume limits, it flows out of tank through overflow hose. When pressure drops in the radiator, it creates a vacuum in the radiator, thus sucking coolant back to radiator from overflow tank. That's why we fill the radiator overflow tank before going out for a ride. If the level of coolant falls below minimum limit. In engine cooling system, radiator fan starts its operation when temperature exceeds a particular temperature value. It helps in lowering the coolant temperature by blowing air through radiator fins, thus removing heat at a faster rate from the coolant. It is regulated by the data from the coolant temperature sensor. Coolant temperature sensor is a multi-purpose sensor as its data is required in optimizing the performance of modern equipped engines. What's interesting is that we let the hot coolant flow through the another heater core and make the air blow through it using blower, thus using this heat to keep ourselves warm in car in winters. If you liked this information, then don't forget to like, subscribe and share.